power generating source. Okay, so solar, windmill, that's the future anyway. Not all data centers have this self generating power source, but most of them is set up like this, and you have the data center. So let's go into the lobby. Enter the lobby. I share this. I'll put this in the chat. It's a bit heavy while that is loading. Okay. Let's check out the lobby. So a typical data center looks like this. Then let's go into the operations room. I want to show us something close to what the servers, the racks look like. This is the server room. Okay, so this is a typical server room. This is a data center in possibly in Ireland. These are the racks. These are the servers. Okay, all these are servers. Okay, all these are servers. So these are the racks. They are fitted to the racks. The servers, the blades are fitted to the racks. And there is a control center. And look at all these cables. So this is a dedicated cable for this rack, a dedicated cable for the next rack. So the cables will contain all, will connect to all the servers. So all these are servers. The cables will connect to all the servers. There'll be a dedicated power source to all those racks. Of mine. So there'll be a dedicated power source to all the racks. Let's look at the blade. So a typical blade, remember I said each of the racks contains a blade. So the blade are the discs. Okay, so this is a typical blade. It's not this big, it's just the way it was the picture was taken. So this is the network cable that connects the blade to the rack. So when we start talking about storage, okay, this will make more sense. So you look at the description, massive cloud storage requires specialized virtual storage infrastructure. This bunch of disks, so all these are, you have disks, one, I can count it, okay? Can store petabytes of data in a single rack and is used for various Azure workloads, like the Azure Standard Storage. So this console can store petabytes of data, not even terabytes. So that's the whole life of a typical organization. And this is a walkway, walk all the way down. These are other compute blades in a typical data center. So this is what a data center looks like. And this is a cloud data center. It's not a private data center. So this is a typical Microsoft data center. Let's go to the network room. Okay, so this is the network room. all those cables, this is where the connection comes from. Insulated room, temperature regulated, secure doors. So for anybody to even be able to enter the data center, you will need a very high level of clearance. Okay. The last thing I want to show is the I think is the server room, not the innovation room. Okay, not this one. Loading, loading, loading. Okay, it's heavy, very heavy. I'll come back to that. It's taking in minutes. So let's go into our virtual network. So the first thing we're going to look at is networking in the cloud. When we talk about networks, consider a network, a virtual network, as an empty space. Okay, so if you have an empty space, then what do we make of the empty space? You can't do anything with the empty space. So we have to compartmentalize the empty spaces into 1 minute. Yeah. So we have an empty space, okay? And we need to compartmentalize the empty space. And how do we do that? We create subnets. So this is a network, and then this is subnet. So you can have, I don't know, hundreds of subnets in a virtual network, depending on the workloads, depending on the purpose of the network. You can have as many subnets as you want. And your subnets will be created in a subscription. Just like we have our pay-as-you-go subscription, we will have our subnets. Sorry, we have our virtual network created in the subscription, and we have our subnets created in the virtual network. Okay, this guy. I want to bring up my pen. I just want to do some illustration before we go on. That will help us. Okay, portion. Okay, so whiteboard coming up in 3, 2, 1. So if we talk about a typical network, are you kidding me? Is this serious? Let's see if I can use the mouse. So we have consider a virtual network as an empty space or an empty warehouse. So this is Azure VNet. In the virtual network, we're going to have subnets. You can't really create anything in the empty space unless you segment the empty space into smaller partitions. So the smaller partitions are the subnets. The smaller partitions are the subnets. And in this case, we have subnets. Let's give it subnet A, subnet B, subnet C. So in the subnet is where we will be creating our resources. And what are those resources? Servers, virtual machines, databases. If we need to connect storage accounts, okay. Storage. We're going to have them in the subnets. So this is a subnet. Subnetwork. That's what the name implies. Subnet is just a subnetwork. So this is Azure Virtual Network. This is a subnetwork. This is another subnetwork. In the subnet B, we can have also servers. Okay, we can have load balancers. We can have databases. Okay. So consider a typical application. Maybe there's the public facing layer, there is the application layer, there's the front end layer, okay? Front end layer, application layer, data layer. So this might be categorized as a typical application that has a front end, then it has an application layer, then it has a data layer. So database, SQL, some servers, some apps running on this in the subnets. Each of these network infrastructure will have their dedicated CIDR numbers. So this could be 10.0.0.0/16. Is anybody familiar with CIDR numbers? Are you familiar with CIDR numbers? 0.1.0/16.
Yes, a little bit.
Okay, 10.0. So each subnet will have its own dedicated CIDR number. It has to be in the /16 block. Yeah. So it has to be in the /16 block so that every other resource will be created. So this /16 means that you can create 65,000 resources. Let me check. 65,000. That means that 65,000 resources can be created in this network. Okay. And as I'm creating this subnet, that means that 3 minus 65,000. So I have still over 65,000 resources that can be created in this CIDR block. This is 2. This should be 2. 10.0.0.3/16. So these are subnets. Okay. So we create our resources in the subnet. In Azure, we talk about public subnets and private subnets. The public subnet includes everything that can be exposed to the public. You can have virtual machines, public load balancers, You can have app services that needs to communicate with the public. Okay, all those are going to be in the public subnet. And in the private subnet, what do you think will be in the private subnet? Somebody help. What could be in the private subnet?
Your database servers.
Why?
Because just like you said, you don't want your database that could contain customer information if it's e-commerce sites facing the public. Stuff like that, you might want to put it in the private subnet to I guess hide that type of data that contains customer information.
Yes. Thank you. Some people don't want me to use my tablets this evening. I thought this was working over the weekend. So there's going to be public subnets, there's going to be private subnets. The private subnet is where we have our storage services. Everything that has to do with data storage goes into the private. Databases, SQL servers, Azure storage, okay, your blob storage, which is going to be in Azure storage, has to be in the private subnet. Because in a typical environment, you have to route traffic directly into your storage services. Your storage services contain storage information, data, sensitive data, business critical data that you cannot afford to lose. Whenever hackers break into environments, especially if it has to do with ransomware and all those things, they go straight for your database. They go straight for your storage account and lock it out until you pay some money, because they believe that there are some sensitive data. You see, identity theft, massive identity theft that is recorded, data breach. Sometimes you hear that an organization has experienced a data breach. Somebody has penetrated into their storage environment and stolen data or corrupted data. So you want to make sure that the data storage are not exposed to the public. So there are ways we can protect access to those storage environments. Sometimes you might need, of course, those storage environments will be available to the public, but it has to go through a dedicated route. We have to define the route through which those resources will be accessed in the storage environment. So I'm sorry, I couldn't draw as much as I want to. I don't know what's wrong with this tablet that I'm using to draw, but this is an overview. Let's just go into the material. So there's the virtual network. In the virtual network, you can have hybrid connection. So remember, hybrid, whenever I talk about hybrid, that means on-premises and cloud. So we can extend our on-premises network infrastructure to Azure. Okay, so you are not only limited to network in Azure. The on-premises data center can be extended, as you can see here. Okay, you can extend on-premises data center to Azure. This is where we start talking about site-to-site connectivity, point-to-site connectivity, express route connectivity. I've had some organizations where they are 100% cloud. Everything is in the cloud. Their file servers, their data center, everything is in the cloud. No physical infrastructure, except for their computers in the office. So they're not managing any data center. Remember the picture I showed us the other time? It is still loading. Really? So Remember the data center? Imagine somebody has to manage that with their private money. Imagine the cost of investing in that kind of infrastructure. But the cloud service providers have taken over the risk to manage that. Imagine the cost of maintaining the power supply, the cooling supply, like I showed us the other time. Those windmill, solar power systems and everything. So it's very interesting how the cloud technology has evolved over the years. So you're going to have subnets. Remember I said the subnets are segments, partitions of the whole network infrastructure. By default, Microsoft reserves the first 5 CIDR numbers for every subnet created. So Microsoft reserved the first 5. Okay, so I think it's even here. So Microsoft reserves the first 5 IP addresses. For your normal router at home, I think 2 IP addresses are reserved in your router. So if you have ever tried to set up your router for internet, maybe for a Comcast, for your AT&T, 2 addresses are reserved. But in Azure, 5 are reserved. One is for network. Another one is for default gateway. Okay. Another 2 is reserved for mapping the DNS IPs. So another one is reserved for broadcast address. So in the exam, you might come across things like this. Just try to understand how many IP addresses are reserved and what are they used for. Okay. So how do we create virtual networks? Let's go into the portal. Let's start. So search for virtual network. Virtual network. All right, create a virtual network. So when we want to create a virtual network, we have to provide a subscription, right? We already talked about subscription. And now we need to create a resource group. Okay, we need to create a resource group. And is it still tiny? Is this better?
Yeah, it's better.
Okay, so we need to create a resource group. If we don't have one already, you can actually create a resource group outside of this location, but Azure has made it very easy. So you can just come right here and create your resource group. So we are building an application for a payment system. So payment system, what's the name of the company? Let's give it a name. Let's give it a name. Maybe Madiba Payments. Okay, that's the name of the resource group. So this resource group is where we are going to have all the resources for this network infrastructure created. Madiba Payments. This is the name of the application. So always have a naming convention. So if you are building an application, name your resources after that application for easy accessibility, for easy location. Because as your business grows, as your company grows, you might have a situation where you have like 100 virtual networks. How do you trace them out? How do you know which network is serving which resource, which service? Okay, so best practice, come up with a naming convention, come up with a policy that determines how the company allocate names to resources. So this is a project for Madiba Payments, is a online mobile payment system application, whatever you want to call it. So the virtual network name is going to be what? Madiba
Mr.
Payments.
Felix, quick question for you.
Yeah.
I don't know if you talked about this earlier, but is there a restriction as to how many VNets that you can have in
In a
a subscription?
Yeah, let's check the quota.
Because I know in AWS, I think you're restricted to 5.
To 5.
Yeah,
I've never experienced that though.
okay.
I create, maybe it's because of the kind of subscriptions I use, but I've never experienced that. So let's check under quota. Go to subscription, usage, let's usage and quota. Usage quota. Go to networking. Virtual networks. 1,000. Oh, yeah.
Oh, wow. Okay.
1,000.
Good to know. Thank you.
Let's check according to region. So this is East US. Let's check East US. $1,000. You can have up to 1,000 virtual networks in a subscription. You can have up to 5,000 security groups, network security groups. Yeah.
All right. Thank you.
Yeah. You're welcome. So we're creating a network. I'm going to copy this because I might use it somewhere else. So where's the data center going to be located? The data center for this virtual network is going to be located in where? Where? Where is the data center going to be located?
You picked East US region.
Yeah, it's right here. The data center is going to be in the East US. So it can be either in Virginia, it can be one of their data centers in the East, maybe New York, whichever location that falls under. Okay, before we go ahead, security. Do I want to enable Azure Bastion? So Azure Bastion is like what you call, or maybe what you're familiar with, jump server. So it helps us filter access to our virtual machines. Best practice requires that port 22 and port 3389 on our Linux and Windows servers should not be exposed to the public. So the virtual network has a service that helps secure access to those servers. So when you connect via Azure Bastion, your virtual machines do not need a public IP address. Azure Bastion provides secure RDP and SSH connectivity to the virtual machine. So get familiar with Bastion, pretty straightforward. From here, I can activate firewall for my virtual network. Okay. All these features can be modified even after setting up the virtual network. But I can always toggle this button right now and set this up from here. So there's also protection against distributed denial of service. So this is DDoS is a type of attack, security attack on network infrastructure. The basic tier comes with your virtual network by default. But if you want to enable standard pricing tier with additional benefits and support, I can check this box. So all these are security tools to help protect the virtual network. and the resources that are going to be created in the virtual network. So I don't need all this right now. IP addresses. So if in a typical environment, you will be given the range of IP addresses you'll be using in your organization. So let's check out this. Let's add our IP address. Remember, I said that each virtual network has its own CIDR block. So this is a CIDR number. /16 means you have over 65,000 of resources that can be created in this CIDR block. Okay. Add a subnet. Reduce this. It's too big. Give me a minute. Let me reduce the screen. I think there are some things I'm not seeing. Okay, let's come back. IP addresses. Add a subnet. Review. Okay, you can see it's
Your
exposed to
interface is quite different from what I'm seeing here. I don't know if it's the same for other people.
Are you
For this
following this?
virtual network.
Don't follow this, so
No, I'm not creating. I'm just checking out the.
we'll check it out. We'll see why it's different. So I just created a virtual network. Let's go into the virtual network. So when you successfully create a virtual network, this is what you have. So remember I said the virtual network is an empty space. So this is an empty space right now. There are no resources. You want to check what resources are connected or what resources services are running in the virtual network. If you go under settings, check out connected devices, subnets. They will give us those information. So let's check. Do we have any device? No device connected. Do we have subnets? No subnets created. No bastion server. Remember, I said you can always come back to modify your settings. You know, we had the option of creating the bastion service. Now, very quickly, for those of us that are using our credit card, if you create any of these services, okay, bastion, firewall, please delete it before you shut down your computer, okay? Because before you know it, you can get like $100 on your bill tomorrow. They drain very quickly. So they are very expensive resources in Azure. Firewall and Bastion, very expensive. So I'm not even going to toggle this button right now because I don't want to forget to turn it off. So just note that the Azure Bastion protects access to our virtual machines. That's the key thing. And of course, what does the firewall do? Perimeter security of the network. So for every request coming from the public, it has to pass through the firewall. We're going to go back to the firewall in a bit, but I'm just showing us some cool features in the virtual network. So we can go ahead and create a subnet. So for every virtual network, there is a gateway subnet. There's one gateway subnet associated to every virtual network. Okay, and every subnet has its dedicated CIDR notation. But the CIDR notation will be, cannot be greater than the CIDR notation at the virtual network level. Okay, the CIDR block for the virtual network is greater than the CIDR block for the subnet. Let's give this subnet a name. Madiba payments subnet 1. And it has already created an address for me. All right. Do I want to enable NSG? Okay. So network security group is a security resource for managing how traffic is routed in the network. So the network security group will help us secure access to the virtual machines, to the subnets. Maybe we don't want inbound traffic. We want to disallow inbound traffic or outbound traffic to a specific resource. We can configure those rules in the network security group. And best practice, make sure you have a network security group configured for your subnets as a security best practice, so that people don't hack into your account and begin to run out your credit. So I'm going to attach this subnet to an already created NSG. We call it NSG for short. If you want to create a route table and route your traffic using the route table configuration, then of course that means a route table must have been created already. In this case, we don't have any route table, so let's just save. Just created a subnet. So this is a subnet in Madiba Payments Virtual Network. I can add another subnet. Remember, you can create up to 1,000 subnets. Sorry, 1,000 virtual networks, but even more subnets within a virtual network. So let's give this Madiba Payment subnet 2. So now I have a dedicated address range. You can see the number of resources that can be created on this CIDR address. Remember the other time I said 5 addresses are going to be reserved. So the first 5 addresses are going to be reserved, regardless of your CIDR block. So always make provision for those first 5 reserved addresses whenever you want to create a resource, a subnet in Azure. We're going to create a gateway subnet. We'll need a gateway subnet when we are creating VPN connections, when we are setting up site-to-site connections, when we are setting up point-to-site connections. We will need the gateway subnet. It's a dedicated subnet, and it's going to host the virtual machines that will power the VPN connections. Even though as a user, you're not going to be interacting with the virtual machines, but just know that for VPN connections is managed on a virtual machine, which you don't get to interact with. Okay, so the virtual machine is in the dedicated data center, and the folks that manage those get busy every day. Okay, so this is a gateway subnet. Remember, you have one gateway subnet for every virtual network. All right, so these are just the steps that talks about how to create the virtual network. So let's look at how to plan for our IP address. Remember the other time I said we have public IP addresses, we have private IP addresses. In AWS, they just call it subnets. There's a public subnet and private subnet, right? It's just name change. It's still the same thing. When you see private IP address, public IP address, they are attached to a subnet. So everybody just want to create special names for themselves. Okay, so in the private IP address, which is going to be associated to a subnet, Those are some of the resources you might have in your private environment. Express route connection, VPN gateway, virtual networks, on-premises. Those are resources we can have in a private IP. Also, databases. Okay. Storage. So if anybody asks you, what are the resources that should be in the private IP? The first thing that should come to your mind is databases. Anything that has to do with data storage. Databases, storage accounts has to be in the private IP address. In the public IP address, which is also the public facing subnet, everything that can afford to be public, everything that can be internet facing and public facing. So for instance, if you are dealing with a banking application, users signing on their phone, on their computer to their banking app, they are able to check their accounts. They are able to check the balance on their accounts. They're able to make payments, make transactions. That service is on a public address. Is internet facing. But when you come into the bank and you are making some inquiries, maybe they need to open an account for you. Okay, so the platform, I know that back in Nigeria, there was a popular application they use in the banking environment, Finacle. I think it's owned by Oracle, Finacle Core Banking. So that kind of application that will be used to open your bank account will be hosted in the back end, in the private subnet, because it's not supposed to be public. It's internal, it's for internal use. Customers don't need to set up the account themselves. So the application that will be used to set up the account will be in the private subnet. Another use case, if you are running an insurance application, okay, if you are setting up an insurance application, you log into the website or you set up the app on your phone, you provide your username and password, you are able to check your insurance information on the go. The server making it possible for you to access those information is public facing. Even though you can access your data, sensitive data, right? Personal data. But because you have authenticated, so there are a lot of processes that goes into that. You have authenticated into the app, you have proved that your identity is correct. That's why you can access your sensitive data. But the services that is being used internally to manage your insurance data is going to be locked into the private network. Your healthcare records are going to be locked into the private network. It's going to be routed through dedicated services for access. All right, so note that there is a public IP, there is private IP, and you can have multiple public facing subnets. You can have multiple internal subnets, private subnets, load balancers. All this can either be public or private. Another thing I want to bring up is the type of addressing we have in Azure VNet. There is a static IP addressing and there's a public IP addressing. So with a static IP addressing, which is what you'll be using most of the time, of course, they have their different use cases, but to be on the safe side, it is recommended to use static IP addressing. Of course, is more expensive than dynamic IP addressing. Why do you think static IP addressing would be more favorable than a dynamic IP addressing? Anybody?
I think with static IP address, it will require the intervention of support most times to get it set up.
Intervention or what?
Support or users.
Thanks for the effort, but the answer is staring at you. If you can see my screen, I just want somebody to talk. I don't want to be the only one talking.
So if the IP address is dynamic, so whenever you probably restart the machine, it might pick up another IP address. But when it's static, so people can, if there's a certain link to reach that machine, so it remains the same. So you don't have to be updating users about the new IP address.
Yeah, thanks. So if you are dealing with servers that are identified based on IP address numbers, IP addresses, right? In the event that a maintenance, so we are dealing with virtual machines, and let's go back into the data center. So remember the data center and remember those racks. So those racks, they go under maintenance. We have data center engineers, data center technicians that maintain those racks. There might be a data center failure. This is a whole data center. There might be a power loss. There might be a hurricane that cuts power supply. So that means maybe the data center is using the general power source. They don't have their private power source. So if there's a storm, if there's a hurricane, tornado in the area, of course, they'll be affected. Even if they are generating their own power with diesel or their own power plant, there'll still be a little bit of a downtime at the data center. So in the event that there's a downtime and servers need to restart, because you are using a dynamic IP address, the IP address on the servers before the incident will be lost. Once the servers reboot, a new IP address will be generated for them. So those servers that you have pointed to a private link, that you have pointed to a storage account, that you have pointed to a service, that service is expecting a specific IP address. But now the IP address has changed, so there's going to be disconnection along the line. But if you have a static IP address, regardless of whatever happens to the servers, the address remains the same, but it comes with a price. Okay, that's for environments where you are dealing with servers that are identified with IP addresses. So we can create public IP addresses for resources, services, and SKU. So in Azure, we talk about SKU. SKU is a stock keeping unit, like different pricing tiers that are available for a resource. So in the case of public IP addresses, you can either go for standard or basic SKU. So with the basic SKU, I want you to check something out. So with the basic SKU, you are limited to dynamic IP address. But if you go for the standard SKU, okay, you'll be able to use a static IP address assignment. Okay. So note this, get familiar with this. With basic SKU, you have access to dynamic IP addressing. We'll test this in the lab. When we do this in the lab, you understand better. Okay. And then there's a standard SKU for static IP addresses. But as soon as we have a DNS setup for our servers, forget about, you can have anything behind your DNS name, your domain name. Okay, that's the solution. So if you still want to use dynamic IP addresses, so once we have a domain name set up for our servers, and nobody cares about the IP address. The service is going to be pointing to the domain name, regardless of the IP address sitting on behind the server. behind the domain name. It doesn't matter anymore. So the port, the IP address for google.com could be 808080, right? But nobody cares about the IP address. This website has its IP address. But do you want to be memorizing the IP address? If I ping this website, we will see the IP address. But it's not the best practice. Nobody will be memorizing IP address. Imagine all these sites I've opened, they have their IP addresses. So imagine if I have to memorize the IP address for all these services, for all these websites. So those IP addresses are sitting behind the domain name of these sites. So once a domain name is configured for the server, regardless of the SKU, is that standard or basic IP address SKU, it doesn't matter. It won't affect it. Even if the server even goes onto a reboot, it's still not going to lose that initial IP address. So we can get to create an IP version 4 or IP version 6. Most of the time, I only deal with IP version 4. I've never had to configure an IP version 6. But you can research and see if there's some new things you might want to know. Okay. So read up on dynamic and static IP addresses. Does everybody have this resource, this material? This is available publicly. It's not hidden. So we need to associate our public IP address. So we can associate the public IP address to all these resources. We can associate a public IP address to a virtual machine, to a load balancer, to a VPN gateway, to an application gateway. Okay, so the virtual machine has a network interface card, which it uses for its networking functionalities. Okay, when we get to virtual machines, we will explain further what that means. Same thing applies for private IP addresses. So you can have virtual machines that are internal facing, okay, that are private, that are sitting in your private network. You can have internal load balancers. You can have application gateway. Okay. So in the lab, we are going to be creating a virtual network. I'm going to create virtual machines. You're going to connect to the virtual machines using RDP. So it's getting more interesting. I'm going to play this video. Share again.
I have a question before you play.
Yes.
So assuming we have 2 virtual machines created, so is it that the only way we can differentiate between public facing and private virtual machine is by the IP addresses?
No.
Okay.
What is going to be in the virtual machines? What is it hosting? That's what it determines whether it's going to be public facing or internal facing. So in your organization, if you have internal communication channels, right? Maybe you have Teams, you have Teams channel, you have Slack channel, you have Jira. Is it going to be public facing? The server where you host your Jira, your Teams settings, is it going to be public facing?
No, it's going to be private.
Yeah, because the customers don't need your conversation now. You are talking to your manager over Teams. Does that need to be exposed to the public? You are talking to your colleague on Jira. You are working on a project together. on Jira. Maybe if you're a DevOps engineer, you are working on a project, maybe in Azure DevOps, okay? And you don't need to expose that to the public. So connection to those services will be locked down to internal access. But anything that has to do with customer facing, public facing will go public. So the purpose for setting up the resource will determine where you locate it. It's not like, oh, this is a virtual machine and this type of virtual machines are dedicated for internal. No. The use case for that resource will determine where you locate it. Database is for storing data. Naturally, you're going to lock it down to the internal network. You're going to protect it because you don't want it to be exposed to the public. So I'm going to play this video. It's 10 minutes. Make sure you sit and watch. Don't run away. I'll come back once this is over.
Welcome to this exam guide to Exercise 4 of Microsoft Azure Fundamentals. To navigate this guide, follow the prompts on the screen, or use your forward and back arrows. Microsoft Azure Fundamentals is made up of 22 exercises. This is Exercise 4. In this exercise, you'll create a virtual network. This exercise is made up of 3 tasks. In this first task, you'll create a virtual network. Follow the prompts to complete this task. From the Azure Portal homepage, click the Menu button in the upper left corner. Select Virtual Networks. Click Create. Under Resource Group, click Create New. Provide a name for the resource group and then click OK. On the Create Virtual Network blade, provide the details as shown on your screen. Leave the defaults for everything else. Click Next, IP addresses. Click the Delete button to remove the current IPv4 address space. Enter the new address space as shown on your screen. Click Add Subnet. Enter the subnet details as shown on your screen. Click Add. Click Review and Create. When you see the notification that validation passed, click Create to deploy the virtual network. This task is now complete. Click anywhere to continue. In this next task, you'll create 2 virtual machines in the virtual network. After the deployment is complete, click click the Menu button and select Virtual Machines. Click Create and then select Virtual Machine. On the Basics tab, fill in the information as shown on your screen. Leave the defaults for everything else. Click Next, Disks. Leave the defaults and click Next. Make sure the virtual machine is placed on the VNet1 virtual network. Review the default settings, but do not make any other changes. Click Review and Create. After the validation passes, click Create. Now you'll repeat the process to create a second virtual machine in the same virtual network. Make sure the second virtual machine has a different name and different public IP address. We've just skipped ahead in time to when the second virtual network has been deployed. As you can see, it has a unique name and public IP address. This task is now complete. Click anywhere to continue. In this task, you'll test whether the virtual machines can communicate with or ping each other. Click to open VM1. On the Overview blade, you can see that its status is running. Click Connect and select RDP. Keep the default options to connect by IP address over port 3389 and click Download RDP file. Open the downloaded RDP file. When prompted, click Connect. Enter your user credentials. You may receive a certificate warning during the sign-in process. Click Yes to create the connection and connect to your deployed virtual machine. You are now in your virtual machine. At this point, you'll follow the same process to connect to the second virtual machine via RDP. For our purposes, we'll fast forward to when both virtual machines are connected. The next step is to disable both the public and private firewalls in both virtual machines. Open the search box and navigate to Windows Defender Firewall. Click Turn Windows Defender Firewall on or off. Next, modify the firewall settings for each type of network by clicking Turn off Windows Defender Firewall. Click OK. Behind the scenes, we have also disabled the firewall on VM2 the same way. Continuing on VM1, open a PowerShell command prompt. Try to ping VM2, which should be running. You have successfully pinged VM2 from VM1. This exercise is now complete. Click anywhere to continue. You can now click below to continue to the next exercise, or close this guide and return to the menu.
All right, so this is just a summary of what we've been talking about since we, in this case, they went on to create virtual machines and pinged those virtual machines, and they were able to communicate with each other within the network. So the virtual machines are within the virtual network, and they were able to communicate with each other. So let's check out some questions. Number one, a subnet has address range which IP address can be dynamically assigned? Pick one. Can everybody hear me? Okay. Final answer. I see more B's. Final answer. I see more A's. Let's do A. Number two, the infrastructure team has implemented firewall rules to deny traffic based on IP address ranges. Which feature meets the requirement? So there's a firewall rule there's a deny firewall rule. So what kind of IP address will I use? Final answer. What is your final answer? A, B? A. All right, let's go for number 3. Which statement about Azure Virtual Network is correct? Which of these statements is correct about Azure Virtual Networks? Final answer? B. Okay. Any address in the range of 10.3.0.4 is available assignment. Okay. That's for number 1. A subnet address range for 10.3.0/16, which IP can be dynamically assigned. The one that is most interesting is this number 2. So these are things you might deal with in the working environment. So look at the rule. By default, firewall rules, best practice, always create static IP addresses for devices that will be connected to your firewall. Because, when you are creating the rules, you have provided the specific IP address for that server, for that resource. So if there is a reboot of that server, which unfortunately has a dynamic IP address, the firewall will still be expecting connection from the previous IP address of that server. But because it's a dynamic IP address, there has been a system reboot, it has now gotten a new IP address, it will not be able to connect to that device. So use static IP addresses when we need to integrate our servers with the firewall rule. And number 3, Azure VNets can connect Azure resources, including virtual machines, app services. Okay. So let's do you have any question?
I do. Going back to that number 1, I mean, is it because the first 3 IPs are reserved, or
Yes.
why can't we?
Yes. The first 5 IP addresses are reserved. And this is between, this is number 3 or number 1, this will be number 2. Okay. So the first 4 addresses are reserved, and this fall in that bracket. So we can use it. You'll not even be able to use it.
Thank you.
Yep.
So I want to make a statement. So I want you to confirm if it's right or wrong. So before we can create a virtual network, we have to create a resource group. So within resource group, we can have as much as virtual network, and within virtual network, we can have as much as virtual machine, right?
Come again.
Okay. So before creating a virtual network,
Yes.
we need to create a resource group. So within the resource group, you have as much as virtual network. Then within the virtual network, we create as much as maybe 1,000 virtual machine.
No.
Okay.
You have a resource group. So remember I said the resource group is like a container that hosts every other thing you are going to be creating in Azure. Your resource group will be created in a subscription. Then your resources, which include a virtual network, a virtual machine, storage, databases, will be created in the bucket called resource group. So when you want to create any resource, you have to create it in a resource group. It's just for us to be, is a logical grouping of the resources so that if you need to manage the resources in one location, you can locate them. Maybe you already have a naming convention, so you can trace them to a specific resource group. So all these services supporting your payment system are within a dedicated resource group. You can always come back and if you need to delete the resource group. So in the lab, you will see sometimes when we'll be told to create your resources in a specific resource group, and then you will see the command that says, okay, delete the resource group because you don't need the resources again. But if you have created virtual machine in resource group A, the virtual network resource group B, you created the storage in resource group C, everything is scattered all over the place. So how do you trace them? How are you sure that you were able to delete all those resources so that you don't incur costs? So the resource group is a logical grouping of all the resources in Azure. Okay?
All right.
Yeah. So before we go, let's spend the next couple of minutes to talk about security. Security in Azure. So the first service we look at is the network security group. So this is a scenario. The company has several sites. Users company will use an enterprise resource planning app to migrate to Azure. You need to secure both virtual machine networking and Azure services networking. Your goal is to prevent unwanted or unsecured network traffic. So emphasis on network traffic. You want to configure inbound and outbound traffic to these virtual machines. So what do we need? We need to create security rules. Okay, you need to associate a network security group to the subnet or network interface. Remember, the virtual machine, its own means of communication is through the network interface card, which is like a SIM card in your mobile device. So let's see how that works. Let's create a network security group. NSG. Let's go ahead and create one. Remember, every resource is created in a subscription. Sorry, every resource group is created in a subscription. So now we want to create a network security group, and we have to specify the subscription. We have to specify the resource group. So if we already created a resource group for this purpose, I can just go ahead and select it. Okay, if I didn't create a resource group, I could have just create new from here. So what's the name? Let's name it after the application, Madiba Payments. Dash NSG. So the data center is going to be, let's put it in Japan West. It doesn't matter. And create. Where is it? Okay. So if you want to control how network is routed to our servers, if you want to control how network is routed into the subnets, we can use the network security group to configure that routing. If you want to allow inbound or outbound traffic, network traffic to the servers, to dedicated subnets, we can use network security group. So the network security group consists of rules that has been pre-configured, and the rule will guide the kind of resources that can be created in the subnet. The rule will guide the kind of traffic that will be allowed into a virtual network. So if it's for a subnet, we can assign NSG to subnet and create demilitarized zone, DMZs. So if you see DMZs just saying demilitarized zone, like, okay, this is a confinement, this is a containment. We will monitor the activities in this environment so that we can test, just regulate traffic into a specific environment. So the NSG will restrict traffic flow to all the machines within that DMZ. So the DMZ is actually sitting in a subnet, and we can monitor how traffic is routed into that subnet using NSGs. That you can also associate with virtual machines. And what will make that possible is the network interface card, which is embedded in the virtual machines. So let's look at the rules. You have the name, the priority, the port information that needs to be supplied. Let's go back into the portal. Let's create. So by default, we have these 3 inbound rules and 3 outbound rules, which cannot be modified. Okay, so for every network security group we create, you will have these 3 rules that cannot be modified, that you cannot delete them, you cannot edit them. So what the first rule is saying under the inbound security rule is that allow virtual network ingress, allow traffic into the virtual network. Okay, allow load balancer traffic. Okay, allow inbound traffic for load balancer, allow inbound traffic for virtual network. Now I can add more. So maybe I want to modify my inbound security rules. I have Linux servers in a subnet, and I want to manage the traffic. Maybe I want to expose port 22 on my Linux servers. So I can modify my inbound security rules, add. So what's the source? So it could be addresses. Maybe I want to allow dedicated range of IP addresses, or I have a specific IP address, or a service tag. Okay. So a service tag could be any of these dedicated services in Azure. Maybe I want to route it through the virtual network or the load balancer, or a specific virtual network in a location. Virtual network or storage. Let's look for storage. Okay, maybe a specific storage in West US. So storage accounts created in West US. We want to route traffic. We want to configure the traffic access to that storage. So I can use my network security group to configure that traffic. But I'm just going to leave. I'm not going to make things more complex as they are right now. Go back up. So let's just leave it as internet, so all port addresses. So I'm not going to specify the ports. I'm going to expose all the ports. So star means all. So this is going to be binding on all port addresses. And port address can range from 80 to 10, 24 to 65,000. Service, customize it. But in my case, I'm dealing with a Linux server. And you know, the port for Linux servers is port 22. So I want to allow traffic. Then there's a priority number. Very important, pay attention here. The priority number takes precedence in order of creation. So the lowest priority number takes precedence. So if I have a priority number with number 100, number 1000, let's make this, you can give it any number. The lowest I think is 100. Allow any SSH inbound, add. I can also say I want to allow any RDP. Okay, allow it. I'm going to give this port number 500. Okay, so I have added to the rules. So the ones I've added, I can delete them. I can modify them. Okay, so the lowest number, priority number takes precedence. So this will be more applicable when we have different applications. We need to access using the NSG rules. So if you already have a lower priority number that overruns another rule that you need to function on the virtual machine, the lower number will kick in first. So if there's no resource for that lower number to support, it will now hand over to the next number. So the lower number is 500, the next is 1000. It will first look for RDP connections before it now go ahead and allow Linux connections. Okay.
So
once,
question, Mr. Lekon.
yes.
So, I mean, I know there's an exclamation mark there. I mean, you're allowing traffic from any RDP connection and any SSH connection. Isn't that like a security issue right there? Isn't that why it's flagging it?
Yes, don't try this at home.
So I mean, sorry, I mean, you know me, you know my
I know,
background. Yeah,
yeah.
so
For
that's
the
why I've been
benefit of
keeping quiet.
others. Yeah,
But
for
yeah,
the benefit of
yeah.
others. Yeah, I know. Usually we will say that don't, it's not a best practice. I'm just doing it because it's demo. So never expose your RDP port and your Linux ports. So when I say RDP, that is the port you need to open to be able to remote into Windows machines. And port 22 is the port that needs to be opened to be able to remote into Linux servers, Linux machines. So best practice, never expose this. I'm just doing it because this is for demo. So maybe I also have Jenkins servers that are going to be running in this subnet. So I can specify that port. So Jenkins port 5000. Allow traffic over port 5000 for my Jenkins server. Okay. So if there's a dedicated service that we want to allow, we can always route the traffic. So you can have a lot of rules here. Okay, you can have a lot of rules. I think it's 5000 from the usage and quota list we saw the other time. And
Ah.
once, yeah, go ahead.
So the Jenkins server, what is it used for?
Ah, don't worry. No, I just came up with a name for you. Don't worry. It's just
I know. Yes, I've heard about Jenkins. You know.
it's for pipeline management in DevOps.
Oh, it's used for deployment.
Deployments, yeah.
Okay.
Pipelines, deployments in DevOps. So sometimes you need to, if you need to talk to that server, you need to open the port because you'll be launching the server on maybe on the browser. So you have to open the ports. Maybe HTTP port, HTTPS. Let's see. So these are custom ports, right? You can see there's a port for MongoDB, for Cassandra, for Redis, okay, for LDAP. So when you choose custom, that is where you can now determine your own resource. Maybe I want to expose ports for SQL Server. For SQL Server, that's port 1433. You may be asked these questions in an interview. That was the port for Microsoft SQL Server. If you're applying for a database, a SQL Server database administrator, you should know the port number for Microsoft SQL Server. Let me see if there's Oracle. Do we have Oracle? No, we don't have Oracle, but we have
Is it
MySQL.
443?
Sorry?
Is it 443 or 4?
No. That's HTTPS. 443 is HTTPS. It's HTTPS. You can see that it has generated a parity number for me. Allow any HTTPS inbound. All right, so let's associate this route to the subnet we have created. And how do we do that? Go to subnets, under settings, still under settings. Okay, go to subnets and associate. All right, so now there's a challenge here. All right, so this energy was created where? It was created in Japan. Ooh, we don't have any VNet in Japan. Another thing we want to note is that your NSG rules will only function in the same location where you have the virtual network. So energy is not a global service. So for the subnet we want to integrate, we want to associate the rule to, we will have to create it in the same region. So let's create another NSG and associate it. Deploy. East US. Where did we create the virtual network? Let's be sure. East US. Okay. East US. So East US. Okay, let's change the name. Source group. Change the name. So I created this in another region. Okay, so I created this in East US. Let's destination any RDP. So we want to deny. So this time around, so let's follow best practice. We're going to deny RDP access. Okay. We're also going to deny SSH access. SSH. So deny traffic, inbound traffic to our servers in this subnet. We want to associate this rule to. So let's associate. Now that error has been fixed. So these are the subnets. We have subnet 1, subnet 2. And the cool thing about NSG is that you can reuse it. You don't have to create multiple NSG rules, multiple NSGs, not the rules. Now you can have as many rules as possible, but you don't have to create multiple NSGs. You can have one NSG and add the rules and associate it. Everybody will pick what belongs to them along the way. So that's the cool thing about network security. So I don't need to go ahead because I want to block access on port 22 now. And then I now go back and create another network security group. I don't need to do that. I can just go into the network security group, go to inbound, and add another rule. I want to deny traffic to my SQL server. Deny, add. So any MySQL server database that is created in the associated subnet is this rule will block inbound traffic. So you say, what does it say now? Deny inbound traffic, yeah. So all of this is deny. And same thing for outbound. So if I want to also configure rules for outbound traffic, I can also follow the same process and associate that rule. So I can associate it to subnets. I can associate it to virtual machines. So if I have virtual machines running, I can associate this rule to virtual machines as well. Okay.
So all these things that we're defining, are they? I mean, the security group is at the subnet level, right? I mean, the subnet mask level.
No, don't confuse. Don't get confused. The security group is a security measure for regulating inbound and outbound traffic to the subnet and the virtual machines.
Oh, okay.
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 So don't worry about subnet mask or anything. Just see, you can either allow or deny. So all those things we have done in the demo, those are the features I just highlighted here. So you want to create the rules, you need to give it the name, give it the priority number, then specify the action. Do you want to deny or you want to allow? So you need to specify the action. And remember, there are default rules that cannot be deleted or modified. Okay, these are the default rules, inbound and outbound default rules. And then there is the effective rules. So with the effective security rules, it's going to take an aggregate of all the NSG rules, okay, and pick the most suitable. As when we use effective security rules. It's going to take an aggregate of all the rules. Remember, in this case, we have NSG1, NSG2, NSG2. So if you want to implement the effective security rules, it's going to take an aggregate. So we can use that to, maybe we are not sure which security rules are being applied. If we toggle the effective security rules button, we will get the exact information we are looking for. You can see that this role is attached to an Ubuntu server with a public IP address and a private IP address. So let's look at IP addresses. There is a convention on how we create private IP addresses. Okay. Let's see. Okay. So anytime you come across these numbers, okay, what's going on? Let's try again. Anytime you come across these numbers, know that these are private IP addresses. If the number starts with 10, if the IP address starts with 172, if it starts with 192, these are private IP addresses. Okay, so in Azure, most of the time, the IP addresses start with 10. Some other environments choose to use the 172 or 192. So that is 3 RFC defined IP addresses. I think I'll be able to find it here. No. Okay. So this is the documentation that brought about that decision. All right, that's by the way. Let's see what else do I want to show us tonight before we go.
Yes,
Sir.
I would like to go back to my previous question. So I want to get it more clear. So the security group is like I'm zooming it to be like a routing table, right? Is that
routing table, you are not denying or allowing traffic. Or you are allowing traffic, you are not denying traffic. But
okay.
the NSG gives us that ability to deny traffic.
Okay.
But with routing table, you are specifying which road. When you are using Google Map, it routes you from point A to point B while you use the intersection in point C, So it's routing you through a specific direction. It's not saying, oh, stop here, don't go, stay here. You are not allowed to cross this intersection, But with NSG, it has the ability to deny or allow traffic to specific resources. But with routing table, you are routing traffic to network, to subnet, to servers, to firewall, from firewall to services, to application gateway, to yeah. So
okay, maybe I meant to say a firewall. It's like a firewall, right?
Is a firewall at the subnet level.
At the subnet. Okay, yeah.
The firewall at the subnet level.
That
Then
answers my question.
yeah, so the firewall is security at the network level. We're going to talk about firewall in the next class.
Okay.
Yeah. So when we're talking about network security, the two key components we talked about is the network security group, which is security at the network, at the subnet level, and firewall, which is security at the infrastructure level. So if you look at let's come back. I don't know what's going on with my tablet tonight. So we put our NSG here. This is a subnet, right? We associate it at the subnet level. But firewall is sitting at the entrance. This is a firewall. So every traffic that is coming from the public has to pass through the firewall. Okay, before it goes into the resources, before it goes into Azure Virtual Network. So now we have talked about network security group, which can be associated at the subnet level.
Yeah.
But you only need one firewall for the whole infrastructure. You're just going to set up your firewall manager. So your firewall manager, you're going to create all the rules and how you want to route traffic from the public, say it's public, okay, from the public to the internal resources, okay? So the next class is going to be based on firewall. All right, go ahead.
Okay, so at the network level, so I'm just assuming that the most important thing is defining the rules. I mean, inbound rules. Then when it comes to outbound, traffic, going out of the network, it doesn't really it will not really matter.
Yeah, most cases, yeah.
Okay.
You just so what is going out will not corrupt what is inside, but what is coming in is more dangerous.
It's more dangerous.
Yeah. Any other question? Are we good?
Yeah.
Okay.
No.
So we are going to call it an evening. Thank you all for joining. Okay, before you go, please start the lab. So let's go to the lab. So start lab 4. So please, let's go ahead and start this lab. By Thursday, we'll talk about it. Everything that was demoed is what we're going to do in the lab. Okay? Create and configure virtual network, deploy virtual machines, configure private and public. So play around with the lab. It shouldn't take you more than 40 minutes, but it's okay. If it takes you more than that, you can always start all over again, and you don't need to time yourself. Nobody's going to time you at work. We just give you a task. We did virtual networks, 25 virtual networks, 48 servers, and we give them, okay, give me 2 days. Let me go get it done out of the way. Okay, so nobody's going to be timing you. But please, let's try to do this before Thursday. All right, we've already done this. Domain name service, domain name resolution. So we'll continue from here on Thursday.
Quick question, Mr. Lakem, before you go.
Yes, sir.
Yeah, I just want to know, apart from this clicking through on the UI interface here, is there any other automated way of creating